Well, good morning. What did you think about Wave? Thanks very much. Yesterday, about the same time in the same room, we talked about the features coming in GWT 2.0. And as I think you can probably see now, a lot of those features were developed. Yes, thank you. I have to switch to monitors. But a lot of those features were developed because of the really extreme level of sophistication that teams like the Wave team and some other really large Google apps, including AdWords, they're really, really trying to do cutting-edge types of things, as you've seen. So these technologies that we're working on in GWT, they happen because there's a need, and then we figure out the best solution that we can come up with, and then they are able to take our improvements and continue working, but another barrier has been removed. So we're really excited about Wave, and if you want to see in more detail how the Wave client team built that really nice UI with GWT and how they take advantage of code splitting, which is the topic of our talk today, go see the talk later on about building a Wave client with GWT. My name is Bruce Johnson again. I work on GWT. This is mostly about the compiler output, mostly focusing on code splitting, but there are a few other things that we'll cover too today. But first, in the spirit of what I was just describing, it's leverage, right? You use Java, the Java language, IDEs to construct your client code, and GWT cross-compiles it and optimizes things for you, and we add fancy new APIs. You recompile as the new version of GWT comes out, and good things happen to your code, and often you have to do very little work. That is what I would call leverage, and that's the basic promise of GWT. So would you take this deal? Tweak your app for 1 hour, and you get in return 50% script size reduction. Well, that's exactly what you get with code splitting. We did this with Showcase. The Showcase sample was available as of GWT 1.5, and we said, we should really use code splitting in Showcase. 1 hour later, Showcase downloads twice as fast. That is high leverage. Similarly with Wave, actually. Wave on the iPhone. Those guys came from Sydney to visit us in Atlanta, and they were talking about wanting to compile their client code for the iPhone, and it was, at that time, a very large amount of code, and it was bringing the iPhone browser to its knees. Well, fortunately, Lex here had just put the wraps on the first version of code splitting, and he spent a day or two with them, and 2 days later, their app was working on the iPhone. And it's just really phenomenal to see the kind of leverage that you can get. So, starting to become redundant now, but just to actually show you quantitatively, 1 hour prior, Showcase was 100K. Then an hour later, it was 50K to download. Another really interesting aspect of code splitting is you've probably seen it now. We've talked about it in several talks in the keynote. Another aspect is it doesn't download code that doesn't run because it actually is based on the control flow of your code. So you don't spend time downloading bytes over the network that don't actually end up running, which is really important from a usability and latency standpoint. When you do download, additional code, even if users ultimately use every bit of functionality in your entire application, you can amortize the cost of downloading that code as they use the app. And Kelly Norton's talk about measuring in milliseconds yesterday, which if you didn't catch yesterday, you should check out on YouTube later. He talks about some certain threshold numbers for turnaround time, and 100 milliseconds is a key number. So if you do 5 things that take 20 milliseconds each, the user's not even aware that anything happens. But if you do one thing that takes 100 milliseconds, the user is aware, and they start to have worse perceptions about the quality of what you're doing. So if you can spread the cost of downloading code around, then it's basically nothing but a good user experience the whole time. Another subtle but important point is, don't think that when you download a code fragment, it means you're hitting the network. If you set up your HTTP response caching headers correctly, you can feel confident that you can cache those code fragments permanently. You can say, this thing can be cached until the sun explodes, because each fragment has a guaranteed unique identifier, right? So no two fragments would ever be confused with each other. Even when you redeploy the application, if there's anything that has changed, it will definitely download the right new fragments. Okay, so again, if you ever hear us talk about GWT, we always talk about optimization, because really GWT is about making the end user experience the best that it can be. Like it is our mission. If some other technology came out that produced a better user experience, we would either try to do better than that, or we would become fans of that technology. It's not that we want you to use GWT. We want you to build excellent web applications for end users. So should you really care about optimization? This is the last I'll say it. Yes. Again, as Kelly explained really well in Measure in Milliseconds yesterday, if you don't think about optimization pretty much from the beginning, you're guaranteed to end up with patterns that are very, very hard to optimize later. And later, if you think about it, is the time when you're about to ship, which is exactly the time you don't want to make architectural types of changes. So the best thing to do is the first few days, just get something going. And then the second week you're working on your app, start thinking about how to measure things and make sure that the resulting application is as fast and small as it can be. So the rest of the talk is about tools to help you analyze that in great detail. There's a couple things we should have said last year that aren't strictly related to code splitting, but that do help you analyze what the compiler is doing. So the first thing is RPC. It's a source of, it's a very convenient way to send Java objects back and forth across the wire. It makes it easy to share source code between your server-side code and your client-side code. Lots of benefits. But it also generates client-side proxy code to serialize and deserialize these various objects. And if you're not careful, 20 or 30% of your total script size can be this generated RPC code. The RPC code generator, as part of GWT, actually produces files to help you understand what is going into the RPC serializer code. And so it allows you to make better decisions about exactly how to define your RPC interfaces, where to use broader polymorphism or more specific types in your RPC interfaces, and use the new feature in GWT 2.0, which is RPC blacklisting. So there's two files. There's a .gwt.rpc file that you're supposed to deploy onto your server, which acts as sort of a safeguard so that an incoming RPC payload is only allowed to ask to instantiate types that this whitelist file, the .gwt.rpc file, says are okay to instantiate on your server. So it's somewhat of a security measure. But it also helps you know exactly which classes the RPC system is considering being available in the serialization process. And then the module.rpc.log file explains in excruciating detail the logic that the RPC generator used to decide whether something should be part of the serialization proxy logic or not. So I'll just show you an example of these files from Dynatable. This is the first one. So these in particular are meant for use by software on the server, but you can look at them as well. So you can just basically read the first column and see, okay, so there's a person class that's serializable. There's a professor class. There's a schedule class. There's a time slot class. And these all correlate to the DTO classes that I'm using within the Dynatable sample that's part of GWT. I can see that there's several different exception types that get pulled in here, and so on. So in this case, those all make sense, but it's also possible that you'll look and find classes in there that you're absolutely sure don't make sense. Sometimes if you use very broad polymorphism, if you were to have an RPC method that returned serializable, for example, the code generator is basically forced to generate code onto the client that can deserialize anything the server might send that is serializable. And so that's an explosion of code. And so you would look at the .gwt.rpc file to get a sense of what is the RPC system really allowing me to serialize. And then you understand the cost for it a little bit more. Then, if you find something that just doesn't look like it ought to be there, you can look at the .rpc.log file. And you want to look at this one second, because there's a bunch of data here. But it goes through, and for any particular class, it will tell you whether it's serializable. Oops. Let me try that again. Whether it's serializable and how it decided that it was serializable. So in this case, student is reachable because it's a subtype of person. And I had an RPC method that returned a person polymorphically. And so the code generator looks at person. It says, well, the server could send either a student or a professor as a person. And so I have to generate serialization code for both. Anyway, this is one of the ways that you can sort of start to learn to read the tea leaves and optimize the size of your client code. Another thing, when you're really trying to eke out every bit of size and speed performance that you can get, is you can actually watch the compiler optimize a method. So this is pretty interesting. So I just created a simple shape example, and this is what it looks like. In on-module load, we have this local variable s of type shape. And, of course, there's the shape class. There's this method on the shape example class that returns a shape, which is a reference to a field, which is defined to be shape, but is actually instantiated as a small square. And a small square derives from square, which defines area to be the product of the lengths of the sides, and then the small square class returns the length of the sides, which good programming practice has us making a constant of 2, right? So if you run the GWT compiler and you provide the -d gwt.jjs.trace methods equals, and then the name of the method that you want to watch, you can see what it does. In this case, the on-module load method, the final compiler logic just before it turns into JavaScript looks like this. And so the purpose of the flag is so that you can actually understand why it's doing that. Even more importantly, if you look at some code and you think it should be optimized, it will help you see what's happening step by step, so that if in fact it isn't getting optimized, you can figure out where in the chain that it's going wrong. So let me show you what that looks like. Let's see. Oops. I'm just going to make this a little bit bigger here. How's that? Okay. So what I've done in each pass here, you've got each of these sections marked here, like the things I'm highlighting, are examples of different passes that the compiler's optimization does. And we're going to be able to trace what the Java code looks like at each step. So here's how it starts out. And what I've done to help you follow the changes, something that's going to be changed is underlined. And then when that thing changes in the next step, it's blue. Okay, so underline becomes blue. So the first thing that happens is we realize that this variable s is actually never reassigned, so we can call it final. Okay, that's kind of useful. Maybe that can serve us down the road. Then the next thing that happens is the compiler realizes that this actually, it does this trick to rewrite call sites so that instead of it being a call to this .getShape, it can be a call to a static method getShape and pass in this as a parameter. There's a really tricky reason for this. In JavaScript, the keyword this is 4 bytes, THIS. That's way too costly. If you can turn that into a parameter and you can then obfuscate it to the letter A, it's the same object, but you save 75% of the code. And that's only scratching the surface, but I won't bore you with the details of those kinds of tricks. Okay. The next step, we had decided that the type of S was final, and so that means it's not going to be reassigned. That means we can actually tighten the type, because we know for a fact that the getShape method, as it was defined, returns a square, and then we could actually see that it ultimately returns a small square. So we tighten the type all the way down to the exact type that is going to be assigned to. The next thing the compiler looks at is this getArea call. It does the same thing with getArea, and you can see here that it makes it a static call. And the next thing it does, both of these lines are underlined. I have no idea if it's easy to follow what I'm doing here or not, but the next thing it does is these two underlined lines get replaced so that what the getShape call gets inlined. Because if you remember, getShape was a simple method that simply returned the shape field. And so why not just make that a direct field reference and get rid of that method altogether? So we've just made it faster because we don't have a method call, and we've just made the code smaller because we don't have to define that extra function. And every function you define costs bytes in the download. So we've inlined the field reference, and then we've actually inlined the definition of the getArea function. But if you'll remember when we started out, getArea was polymorphic. But because we were able to devirtualize, remove the polymorphism, we can actually see that getArea call is the getArea call on small square, which it inherits from square to be side lengths multiplied by each other. And then recursively, we make the same change, and we recognize that, well, okay, getSideLength actually is on the small square class, definitely, and it's not overridden. And it definitely returns the field, which happens to be 2, and we can propagate the constant 2 back into the method and then inline the method. And so then it turns into this. And then 2 times 2, we can do that math in the compiler. Why not do that at compile time? Why make the JavaScript interpreter waste time doing that? So we go ahead and do that. And then it becomes something that we can actually concatenate the string, because there's a well-defined way to transform a number into a string. Then we've got string literal plus string literal. Why not concatenate that at compile time as well? And then the last thing is, we don't need this variable shape anymore, because we've inlined everything it did all the way down into the call site. And so why not just get rid of that variable altogether? And so you're left with optimized code. And it really is convenient for the compiler to do that sort of work on your behalf, so that, as Lars said today in the keynote, you can think about your application and be more ambitious and try to build more, more functionality that's useful for the end users, instead of having to fiddle with the specifics of hand optimizing little bits of JavaScript and so on. All right, that's the stuff we really should have told you about last year. The stuff we're going to tell you more about this year is code splitting. Okay, so why is code splitting useful? It's kind of obvious, but let's get really specific. Traditionally, you download the HTML host page, then you download a large chunk of JavaScript, and then the code starts to run. So this yellow area here, the JS, we really would rather the code start running before all that's loaded, but you can't generally do that unless there's a sound way to split the code apart. So what happens with code splitting is you can break that JavaScript into chunks, and so the user experience goes, load the HTML host page, load the startup fragment, which is the leftmost JavaScript that you see here. Then the code can start running, and because the code splitting API is designed to be an asynchronous fetch of code, the user can continue using the application even while the lazily loaded fragment of code is still being fetched in the background, because the network might take a long time, right? So the application remains usable even while more code is loading. I guess that's kind of obvious, but the net effect is that you see the sum of all the green is the amount of time that the user is able to use the application, and there's a significantly longer amount of time that the application is active, and it stays active the whole time. So ultimately, when you're designing big applications, you should try to get used to the idea of the app never being, fully loaded. It means that the more you can think about various pieces of functionality as being able to be broken off and pulled in on demand, generally the better off you'll be. It's not always strictly true, obviously. I mean, some cases, you definitely want functionality to be immediately available from the very beginning. And that's why this is developer-guided code splitting. You can decide where you're willing to tolerate a delay under some circumstances, or where you're not willing to tolerate it. And you do or indicate that by having a split point or not. But you've probably already seen this API a lot now. GWT.run async, it has a callback on success, happens when the code loads, and then the failure path if the code cannot be loaded for some reason. So now I'd like to introduce Lex Spoon. Lex is the guy who actually invented code splitting and made it all work, and he's going to take you through an example of how to benefit from it and how to understand exactly what's happening if your code isn't splitting the way that you want to. Take it away, Lex.
Thanks, Bruce. So, let's maybe start on the optimistic side and imagine that the code splitting goes the way you want. So, as a running example, you might have an application that can both read and write something similar to an email. It might be an advanced email that Google is about to release later this year. So, as you can imagine, the code to compose an email is actually pretty hefty, especially if you've put a lot of effort into really making each keystroke do exactly what you want. So that's kind of unfortunate if you don't use code splitting, because if you think about the way your app is structured, all the code in yellow in this diagram is code used for composing email, and yet if you don't split any code, all of that has to download before the inbox shows up on your user screen. So this is a good scenario for code splitting, because there's a lot of code that's not needed initially. You'd like to let them start reading email while you download the rest of the code in the background. So to see how that looks, in the initial version of your app, you might have a button somewhere. It has a callback that calls this little method, onCompose email button clicked. And in the initial version, it simply opens the compose view. Well, you'd like to split this out. So instead, what you can do is wrap that exact same code inside a call to run async. So this is just like setting up an event handler in a GUI framework, except the event in this case is that more code has arrived. Now, it is also possible that the code never arrives. So one downside of code splitting is you have to think about that extra possibility, and we force you to also write an on-failure branch of your callback. And that's really going to be an app-specific handler. So that's pretty simple code, we think, and as a result, you end up with something like this. In the initial download, you download the green parts, and you download the yellow parts later. You also initially download this extra failure code, which we all hate to think about, but it is an extra code path that you get. But usually that's pretty small, and so in sum, the initial download of your app's gotten a lot smaller. Something we like to brag about the system is that it's not just your code that gets split up either. The two different parts of your reader, the email reading code might use one part of the standard library. The email composing code might use a different part. And we'll actually split that up for you, too. So as you can see, 2 and 4 are actually from the same library, but they got split in half. So that's when things are going good. If you'll forgive me, I'll dwell a bit for the rest of the talk on things that don't go so well and what you can do about it. So maybe you're the guy who did the initial code splitting, and you're thinking code splitting, code splitting, code splitting. And you got it split out, and you bragged about it at the weekly group meeting, and you showed some nice graphs. Next week, another teammate of yours is thinking keystroke handling, keystroke handling, keystroke handling. And they come into the meeting, and they show you some great keystroke handling code they've written down on the bottom right. You'll notice this looks suspiciously like the original code I showed you for mouse click handling. And the result of writing this code is that your app's going to look like this again. This is a little difficult to deal with, I must admit, because the two different developers, they're just not thinking about the same thing. And so they've both accomplished their task, but unfortunately, the second guy has undone your good work. So first of all, I'll show you what to do in this situation, because no matter how well you plan, things are going to get messed up. And then I'll try to show you some engineering practices you might try to prevent this from happening in the first place, or at least reduce the odds. So first of all, imagine you've got some build metrics, and you notice that, gee, my initial download just went back up to almost the whole program again. GWT 2.0 will include a tool called the story of your compile, or as we like to pronounce our acronyms, it's SOIC. And I think it sounds like some kind of vitamin breakfast shake. And it tells you a few really useful things about your program, including how to debug this particular problem. So it tells you, first of all, it tells you which parts of your code download initially versus later. It tells you how big each one of those is. So this is pretty useful outside of code splitting because you want to, when you're measuring your latencies in milliseconds, every kilobyte counts, and you'd like to know where to focus your efforts on shrinking your code down. And importantly for code splitting, if something's in the initial download, it'll tell you why. It'll tell you what the compiler was thinking when it screwed up your code splitting and put it in the initial download. So let's take a quick tour. If you had a simple sample app that was reading and composing email, if you open up a story of your compile, you'll see something that looks like this. So the front page of it tells you the overall size in bytes of the code that's going to download to users, of the different downloadable chunks of code you've got. So the top line is the entire amount of code you've got. That's if they hit every single run async in the program, and they end up downloading everything. In this case, it's 30 kilobytes. It's pretty small. The next line shows you what they download to start with. And in this case, it's almost the whole thing. So the bar is pretty far over. This is an unfortunate situation. The last line, it just further rubs in the fact that this is what downloads later after they reach that split point. And you'll notice it's such a small amount of code that the graphics didn't even render quite right for the bar. So, all right, so this is what you'll discover. And you'll say, OK, what's going on in the initial download that looks wrong? This is a view we expect you'll be staring at a lot as you try to optimize your program in the future. This shows you the size of different parts of your code broken down in 4 different ways. Today, I'd like to just focus on the top left one breakdown, which is a breakdown by Java packages. So if you go down that top list, it's probably hard to read on this screen, but the top one is java.util. So this is a pretty small app. It turns out that the collection overhead or the implementation of collection classes is actually pretty heavyweight for this app. And then you'll see the third entry is java.lang, so it's more runtime support. You'll see a lot of Google GWT user stuff. That's the widget implementation. And all of this is probably not what went wrong. If you're assuming you kept a fixed version of GWT for all of these samples, it must be the fact that something went wrong in this package, which is, let's imagine, the implementation of your application. Well, if you select that item, it gives you a breakdown of each on a class-by-class basis. So we're drilling down into where we suspect a problem might lie. And actually, now it's pretty obvious. If you're someone who knows your own app, you'll see that this top bar is humongous. It's the email composition view. And especially if you go talk to the person, the code splitter person, they're going to say, that's crazy. We don't use the composition view initially. And you say, well, yes, we do. If you click on this guy, it will go to each method in that class, and it'll tell you why the compiler thinks you need it. So if I can draw your attention to the third entry, the show method, you'll see it's called directly by onCompose keystroke click. That's the method that this fellow just implemented last week. You finally figured it out on Tuesday or Wednesday. And you can go trace that guy down and say, what you should have done is you should have coded it like this. So you show them your compose email method, and then they do the same thing in their compose keystroke method. I call this the whack-a-mole solution to code splitting. This is you get it the way you want it to work. You find out there's something wrong, and then you just go look at your dependencies. You pick some method in the chain. In this case, we picked onCompose keystroke click, and you put a cut point right there. It won't always work the first time. Sometimes it'll still be in the initial download. You'll go to here, and you'll get a different set of dependencies. So this is a very reactionary kind of way to improve your code splitting. It will eventually work. You will eventually cut out enough little pieces that you got the part off that you wanted. And you'll eventually get back to here again. However, the whack-a-mole style of problem solving leaves a little bit to desired from sound software engineering practices. You just don't want to be a manager who's watching your product regularly degrade and then having your developers go scramble to figure out, OK, what went wrong, and then fix it back again. So We'd like to come up with some kind of systematic solution to this problem, and I want to tell you about one we've been thinking about. This is a fairly new programming primitive, we think, so maybe there will be other ones coming down the road. But let me show you one that we call the async package coding pattern. This is actually in use by multiple GWT clients already, and they seem pretty happy with it. So the goal of this pattern is that you don't want everyone on the application you don't want every developer to have to understand what every library did for it to get its code split out. What you'd like to do is you'd like to at least narrow the focus down to the developer of our library. So in this case, we want to make the email composition guy think about how to get the code split out. And we want everybody else to just get the splitting automatically. We don't want them to have this tempting method called show that they're not supposed to call, except very carefully. So to accomplish this, what you can do is remove all direct access to the classes in that package. So just don't have a public static method called show. Instead, provide them one gateway class called email composition, and make sure everybody has to go through that gateway class to do anything with your package. You can use Java protections to accomplish this. Make sure that the only way to create that gateway class is inside a run async somewhere. Well, if you can write your app using this pattern, you're in pretty good shape, because you can only get at the functionality through the gateway, and the gateway is only constructed inside a run async. So therefore, there's no way to access the code except after a run async has been called. So that probably sounded a little abstract. I'd like to walk through the way this code looks real quick. So make a gateway class, usually named the same thing as your actual module. Make its constructor private so that nobody but itself can create it. Take all the static methods you have and make them instance methods. This way, if anybody tries to call it, they're going to get a complaint from the Java compiler instead of getting a complaint from whoever's watching the performance of your app who noticed that it just suddenly degraded. Now, to provide access to this thing, make a static method, which is conventionally called createAsync. It takes a user-supplied callback, and then inside a run async, it creates an instance of the gateway, and it calls the callback with that instance. The rest of this is pretty straightforward. If there's a failure to download the code, you just buck that back to the user. And the actual callback interface, as you can see, looks pretty much the same as a run async callback interface, except that in the success branch, there's now an argument. OnCreated takes an argument, which is an instance of the gateway. On the user side, it also looks a lot like just using a regular old run async. So this coding pattern we don't think is going to be very difficult for users to have to deal with compared to what they'd write anyway. The only difference is that in their OnCreated success branch, they get an instance of the gateway, which is called view in this case. And then once they've got that instance, they can do stuff with it, like they can call show and pop up a composition window. So that's a pretty fun pattern. That's the basics of it. I'd like to mention that once you're writing your own gateway class, you're in a position to improve on it. For example, the way I showed it to you the first time, you create a new instance of it every time in every callback. You may as well cache that instance as a private static field of the gateway, so that if they call it again, they'll get the same one. That way you can have the equivalent of variables that are scoped to the module. Another fun one is that the caller doesn't have to always go through the createAsync. They only need to do it once and get an actual instance. So what you can do is you can arrange your code such that it takes instances of that class, such that key parts of your code require an instance of that class as a prerequisite to even constructing that part of the code. This is a dependency injection style where you're injecting dependencies via constructor parameters. So just as an example, if you're writing a spell checking plugin to your composition view, suppose it takes an instance of the gateway as a constructor parameter and then just says this.view equals view. It just hangs on to it. Well, now anywhere in this plugin that you want, you can make direct calls onto the view object. So by having the forethought to save aside the instance of that module, you've made the rest of the code of this plugin pretty convenient. You don't have to sprinkle createAsyncs all over your code. if you save the instance of the view. It so turns out that dependency injection will help you in other ways. If you can stick around for Ray Ryan's talk after this, you'll see how it helps you with testing. You can mock out the view to a testing stub pretty easily once you're using this style. So, yeah, and once you're writing your own, you can improve it in various ways. Like, one of the common things you want to do as a app writer to be user-friendly, if you're about to hit a network delay, you'd like to tell the user that the app hasn't just frozen up. So, and that can happen if you call a run async and the code's not available. However, if the code is available, you don't want to flash an indication up that immediately flashes away. So you could put the onus on the gateway class to figure out whether it needs any more code to download. And you could, for example, add an extra method to the callback interface that says, hey, I need to actually do a download. You might want to pop up an indicator. And then otherwise leave it on. That's just an example. We don't know exactly what the optimal gateway class looks like, but it looks like a promising kind of coding pattern to think about. So that's what we wanted to show you today. We wanted to show you some tools that we provide so that you can help improve your own performance. As much as possible, we try to make GWT just make your app rock. But to the extent it doesn't, we provide several tools that will help you debug what's going on and then incrementally improve. So we showed you how to reduce the code size due to RPC transmissions. This is an extraordinarily common thing to happen with people who use GWT RPC, is that they just accidentally put a type. They try to pass class exception across the wire, and GWT dutifully gives you code to serialize every kind of exception that you have available in your class path. If you look at these files, you can figure out pretty quickly that you didn't mean to send an illegal argument exception across the wire and improve that. We've shown you how you can look into what the optimizer is doing. A lot of times, a small tweak to your code will yield just dramatically better output. You love it when you get output that looks like window.alert and then a string literal. So it's worth trying to tease the optimizer into doing those sort of things. And the only real way you can do that is to actually look at what it's doing. And finally, we've shown you how to use code splitting and how to debug what's going wrong with it if it doesn't do the right thing, and we suggested a coding pattern. So if y'all have any questions, we have plenty of time. You want to come up? Yeah, you want to come up here and answer questions together? Oh, yeah. They'd like you to go to the mics because this is all taped. And
okay, what happens if you call the run async from one point in your code, like you load the code and you want to go get something else right away while the user's staring at your initial page?
Sure.
And then the user's clicks the button, and you call run async again. Is it smart enough to know that the first one's been called? Or was it going to go try to get it 2 times?
Oh, the implementation won't download it twice. But that is a tricky situation for your app to deal with. So in fact, one of the things that people do with these gateway classes, like a common name for them is an asynchronous provider, is they'll track outstanding requests and then be able to do something smart if you get a request to the same thing twice. The system doesn't help you program around that, but if you do nothing, what will happen is the code will load one time, and then it'll run your callback, both instances of the callback you passed in. But you might want to code your app carefully to deal with that.
You wouldn't get redundant requests for the same fragment, though, to be clear.
Okay.
Yeah.
Hi. Thanks. Great talk.
Thanks.
So far, you've shown how the Web Toolkit it optimizes the Java into really tight JavaScript code, and using the code splitting, you can not download more JavaScript code than you need. But I've also heard numerous mentions that it also it packages and processes the style sheet code, CSS code, and any other includes that you put in there. So one question I had is, what happens if you have, say, a style sheet that is you're using sort of a cross project because it's got all the different styles and on objects you want, but you don't need it for the page that's loading. Does the GWT understand that and not load all that code?
Do we have dead? It's not very good at it. Does it at least do dead code removing?
Yeah, so if you notice, did you see the client bundle stuff yesterday?
Yeah.
Yeah. So that pattern of resource bundling, it's based on you call a method in order to get the resource. And so, do you know what I mean?
Yeah,
like
yeah.
You
It
call
makes
a
it into a
method and it
field, right?
returns a text resource, okay? So one of the benefits of that approach, aside from just simplicity, is that you can use normal compiler control flow, dead code elimination type analysis, to decide whether a given method is called at all. And so, and take code splitting out of the equation for a second. If you don't call a particular method that would return a text resource, that text resource need not be bundled in, first of all. So code splitting, resource bundling in general can work well with dead code elimination. That's code splitting aside. When you bring code splitting into it, it gets really exciting because, as Lex pointed out in one of the slides, code splitting can work even at the level of individual methods on the same class. So if you've got one Uber client bundle that's got a whole bunch of different methods, it is possible, in theory. I'm not sure if it does this in practice.
I'm not sure how the bundling works.
Yeah.
But strings, it's great.
Yeah,
so like translation.
to be able to split some of those methods into the startup fragment, some of those other methods into
And
the subsequent.
same with style sheet information?
Right. So it works generally because it's based on the interaction between the client bundle code generator and run async. It's possible that in its current state we haven't fiddled with exactly the way it generates code to perfect that yet, but it is possible. So if the code generator generates a different field per method that gets called, and each of those are independent, fields can be split across fragments. And so you can automatically distribute the resources across the fragment.
And will the debug app that you showed, I can't remember the name of it now, for seeing where the compiler thought the code needed to be optimized and whatnot, does it do the same for other things besides the JavaScript classes?
Yeah, is that sample on here, Bruce?
Well, I'm sorry, were you talking about the story of your compile? Or
Story of your compile, right.
Yeah, that one definitely is. That's
Soy C.
So the code splitter works really well with strings, but it can only work on actual Java code.
Okay.
So it depends on the particular generator. The translation one works really well because each message that you translate ends up as an individual string literal. So in your initial download, you'll get the ones you need initially, and then when you load the composition view, you'll get all the tooltips for the composition view later when you download. So.
Lest the incredibly polished aesthetics of this fool you, this is still very early.
Yeah.
But what we hope to do is provide better visibility for each of the code generators as well. So you'd be able to attribute this amount of code to the RPC code generator, this amount of code to the client bundle generator. We'd like to provide drill downs for all the different mechanisms and also make that a generally extensible mechanism. So if you write your own code generators, it could participate in the same way. But it's, we're sort of still at the beginning of this, and that's the vision for it.
Thank you.
Hi.
Hey.
Could you share any thoughts about the prospects for precompiled shareable or shared libraries in GWT?
Yeah, so I just wanted to show something real quick, is that if you click on, it does show you the individual strings that you're downloading at different points. But philosophically, when you're providing a web server, your users are all going to funnel through a website anyway. And it seems like you might as well insert a compilation step, at least at the funnel point. So for most of the time, you're really better off if you can figure out a way to arrange your application so that there's a place where all the code gathers and you can run a cross-app compile right there. So that's by far where GWT focuses, is you can write modules for programmer consumption, but then when you do your real compile, you put them all together. Now, it is possible to arrange to have runtime linkups of various kinds.
Yeah.
You have to make a bridge through JavaScript yourself but it does work. But as an example, you can compile a Google gadget for people who've looked on iGoogle or things like that. You can provide a gadget with a GWT app, and you could even write a gadget host as a GWT app. And that's going to require that you do a runtime link up.
I mean, in terms of our own roadmap, we aren't very bullish about the idea of precompiled libraries, because as soon as you do that, you basically prevent the opportunity to do dead code elimination, for example, because that's something the compiler would do. So in other words, you saw, in fact, from the story of your compile that just the java.util classes were the single largest part of this particular application. That's with dead code elimination already happening. So if we don't call ArrayList.remove, that method doesn't, the code for that doesn't get pulled in, right? And it's still the biggest chunk. Imagine we cross-compiled everything in java.util, right? That's a lot of code. And it would be really unfortunate to download that to the client when, in fact, you're only using a small subset of it. So I'm not saying never, but we think that this approach, doing lots of optimization at compile time and use code splitting, is going to be ultimately more fruitful.
Yeah, I guess it depends on how many applications you have and how big they are, right?
Yeah, that's true. There's also, though, the sort of, we don't want to create the web version of DLL hell. I think we've all, or many of us have been there too, and that's a really dangerous thing so we're trying to avoid that.
My question, I'm using, let's say, third-party library. Sometimes now it's pretty huge and takes a lot of time. I'm using probably 10% of this library. How in the future are those libraries going to split? Even libraries that guys from Google are writing, and so I suppose they optimize it for split. Or how I can deal with this as a developer?
So far, libraries usually aren't split up for whatever reason. The standard GWT library doesn't have a single call to run async internally.
No.
It just happened. So usually what people have done is split off components at the application level. Things like for the showcase demo, there's a separate run async call for each page of the demo. And for Google Wave, there's a separate split out for the Wave editor. So their application level chunks being split out so far. In the future, I don't know.
To clarify, too, there is a difference. Lex was saying there's not a GWT.run async call within our libraries. Mm-hmm. But that doesn't mean that your run async calls won't be able to split apart your usage of our libraries, of the GWT libraries.
So it's up to me to split kind of in.
Right. But we feel like because the decision about where to split is completely tied in with the user experience, we should generally provide just a traditional code base, and you should make the splitting decisions, and then the compiler will fragment.
Talking about simple stuff. Let's say I'm using table, yes, mm-hmm. or I'm using tree. Tree has a bunch of related classes that's supposed to come together.
Right.
Yeah, that's natural packaging. But because it's a huge library, they have tree, they have grid, they have all this stuff. So I need to split because I know the tree coming all those classes together. Obvious.
Right.
Yes. So.
Yeah, that's.
And I still need to do this by myself. Yes. Yeah. Okay.
Until we can find a way to help you more, and we
please,
will be thinking.
Please
about
find.
Well, you have to try it first, and then you have to complain.
Hi. I have a question about the failure, which in all the examples that you guys have been showing yesterday and today, basically what you seem to be showing is when it says on failure, you just make a little alert to the user, which I think we can all agree is not really realistic for a running application. So I'm wondering if there's any paradigms you guys have thought of for dealing with that, because the way that we write code now, you assume that you have all the code, and this is changing that. I'm wondering what you guys are doing about that.
Ray, are you here in the audience? Ray Ryan? Well, so Ray Ryan worked on the new AdWords rewrite with GWT, and that's something they definitely have to think about. What tends to happen in large applications is that there's a centralized error reporting mechanism. So, we showed window.alert just to be succinct, obviously, but really what that would probably look like is, call the global app instance on error event, or maybe there's some specialized method that specifies exactly the error ID or something. But typically it would funnel to one consolidated error handler that would show some UI to indicate something to the user.
And like, what causes the failure? It's like if the file doesn't load, so it's like a network error.
Yeah, right, like a network error. There wouldn't be spurious errors due to the compiler making a mistake or something like that.
No, never.
Right, like code splitting wouldn't work at all reliably if the compiler could screw that up.
Okay.
But it's perfectly normal that you open your email reader at the airport, and then you walk down the aisle and you reopen your email reader, your laptop at the same page, and you're not on the network anymore.
Right. It's really transient network failures. The server, crashed for a minute, but it comes back up because it's a cluster or something like that.
Yeah, I guess I was just wondering if there's any sort of like general paradigm of like, well, try again. You know what I'm saying?
Yeah, have you been thinking about that? Like having
most apps I look at don't do a very good job if they lose network access. And this is aside from code splitting. If the server's not there, they tend to give you bad behavior. Good stuff I've seen, though, is they pop up a loading dialog when they're trying. Good ones will actually remove that once they realize it's not going to work.
Like
a lot
Gmail.
of them leave it running. Some cool apps will show whether they think the network is there or not. So if a download fails, they'll toggle it off, and you can click on it again to basically indicate, okay, I think I've got a network now. But it's all very speculative.
One thing I've actually heard, just random email threads around Google, is that sometimes you get spurious failures, and just a simple retry, and it will succeed. Not with code splitting, but even RPCs or XHRs, HTTP requests in general. Sometimes the best thing to do is just try it twice before you declare a failure.
Exactly.
And the code fragment loader could do that. I don't know if it does, but
yeah, we might want to do that.
it's a little dicey though to have your libraries do too much magic without your control. So if we can find the right balance, we probably would do that.
We did go so far as if your app retries, the low-level support will retry the network request.
Oh, okay.
So if your on failure retries, it will actually try again.
It's really exactly the same issue when you talk about RPC, because RPCs can fail in exactly the same way. So if your app is one designed so that retry makes sense, then there you go.
Thanks.
Yeah, this is a very low-level primitive thing. Yeah. It's intended to be the absolute kernel of functionality, and then you'll build patterns and frameworks on top of it.
Yeah, so during the demo you showed using the dependency injection pattern, and it's a wonderful pattern. We use it on the server side a lot, but we haven't been able to use it on the GWT side because there doesn't seem to be a good library for it, or at least, I haven't looked too hard. But is there any projects out there that you know of?
Yeah, come to Ray Ryan's talk called Architecture Best Practices.
Okay.
There is such a library. It's based on Juice, which is Google's dependency injection. Okay. It's called Gin. So Gin and Juice are quite the pair. And Ray's going to talk through how you can use that and to build the kind of app you're talking about on the client.
Okay, excellent.
Well, that was exactly my question. We use Gin in 1.5 and Suko on 1.6, and I was just wondering if there was a more general DI.
Gin is the one. It looks like the one that's everybody seems to be liking a lot. So,
thanks.
Yeah.
Hi. It strikes me that the process of getting your what would you call it? Your sections done is an iterative process where you compile your app, you inspect the decisions that were made with story of your compile, and then you break the dependencies where you can and whatnot, and then you try it again. And the first thought that comes to my mind when I see story of your compile is, since this is an iterative process and the issues are sort of same like with hosted mode versus web mode, what effect does story of your compile have on compile time? Because it's an iterative process. It seems that's important.
I didn't quite completely understand it. It is a compile time tool, actually.
Yeah.
So,
but the point is it's generating a lot of data, right? How does it affect my compile time when I turn on story of your compile?
Well, Catherine is laughing in the back row, I see.
Some folks who've been
it increases the compile time, and we try to keep the increase as small as possible and on different days. But then we want it to output more information. It gets worse again. So it is optional right now. If you want the fastest compile, you disable it.
I see.
Yeah, we would love to make that as fast as we can. And, there's now the Google plugin for Eclipse, and it does sort of incremental, ongoing compiles as you make source code changes. Maybe, possibly, in the future one day, we could kind of build that story.
Or maybe consider having an analysis mode, compile mode, where you don't actually go through the whole generated code, but you just do the dependence analysis and write that out.
Right. Basically more control over how much stuff you track. Yeah, that's a good point.
It's a good idea.
I think I really see the gist of your question and point now, which is you don't always want all the data for different types of use cases of using it. I got you.
Do you have any suggestions on how to get your code splits to preload in the background?
Well, you do want to do it, and it doesn't do it automatically. So a common trend with GWT is that we provide a very low-level tool, and then we try to figure out the best practices, and then we import them back. Is that fair to say?
Yeah,
as we figure out what they are.
Yep.
Right now, what you can do to, if you use the async package pattern, what you can do is have some part in your code that just does a chain of these calls in the order you'd like to preload them. So it's a little bit verbose to do that, but that's a pretty effective way that you preload one at a time. And you can even have these preloaders check if your app has any indication of there's something the user is actually doing. So then you can even not do the preload yet until the app quiesces.
You could set a timer and then cancel the timer if there's any interaction with the app.
That kind of thing.
So because you wouldn't want, say, an RPC to be usurped by a prefetch of a code fragment. And that's why we don't do it automatically, even though it's kind of obvious that we might want to. But the network connection is so precious. You might have real-time RPCs that need to happen in response to user action. You don't want to do that you don't want to usurp that by loading code in the background.
Especially if you think about mobile devices. If you start downloading code, the network is swamped.
Right. So it's really easy to saturate the connection with stuff that you might not even use. Right?
No, absolutely. I see where you're coming from. I'm just thinking, from a user perspective, if they know they're going to walk away, to use your example, from where they have connectivity, they might want to, click a button that says, "Let me go offline with this."
Actually, I think the way we might want to solve that is through the HTML5 app cache. There's already a linker. I think it's in the incubator that can take a GWT module and produce the app cache manifests and everything. Okay. We haven't done this yet with code splitting in mind, but it would be possible to create such a manifest so that you can essentially download the whole app, including its fragments, to the app cache locally. And then it would be a fetch, but it would be a fetch from the local app cache, not over the network. That would be really cool.
Thanks.
Yeah.
This is somewhat of a vague question, but I'll ask anyway. Going back to the point you were just making about sort of modulating what you download based on user activity or potentially what else is going on in the application. What do you see as being sort of the other type of input that you would put into that decision? In other words, we talked about, there's some discussion about 2 images sort of blocking up all the connections, other activities going on, some information maybe it's trying to render something heavy. What do you see that the GWT app itself would ever get more information about what's going on the page or with the browser that would help drive that sort of a thing? What kind of things are going on there? I guess that's my question.
A hardware telepathy interface. That would be awesome.
Yeah, seeing the future. I always thought of it as app input mostly, not browser input, but I'm not sure.
Well, the thing that's tricky about it to me is that sometimes if nothing is happening, it's because the user is deciding what they're just about to do. So just because they haven't done something for 2 seconds, that might be the indication that they are about to do something, not that they're not about to do something. And so I'm not sure what the right answer is at all.
It would help if you could tell a browser that this is a low priority download.
Yeah, that would be cool.
I don't think you can.
That would be cool. Also, the pressure is being reduced somewhat. The newer generation of browsers do allow many more than 2 outgoing connections. So that will be, mitigated, I guess, somewhat. Well, we are out of time now. There's one thing that we need to do here, which is to ask you to fill out this. Provide your feedback, and if you have anything to say, we would really like to know it so we can make I/O even better for you next year. Thanks very much for coming.
Thanks, guys.